S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
In part 1 of this lecture, we did understand what exactly indeterminate forms and the rule L Hopitai, how we apply that rule for indeterminate forms. So, in part 2, we'll continue with this, and different problems, or you can say little difficult problems we'll be taking. And in part 1, we have done not a few examples based on L Hopitai rule. Hello everyone, I am Dr. Seema Thakran. If you want to know the concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. So let's start with the problems based on indeterminate forms and L Hopitai. So my next problem is limit x tending to infinity e to the power 1 by x minus 1 by x. So you can see when you are substituting x infinity, this is 1 by infinity, this term 1 by infinity will become 0, e to the power 0 1. So e to the power 1 by infinity minus 1 by infinity is 0. So this is giving e to the power 0 minus 1 and 0. So again 0 by 0. So at this time the change is that the limit is x tending to infinity, but you will apply, this is in determinate form and using, for these forms there is only this L Hopitai method we have. What to do? Again differentiate and carefully. So e to the power 1 by x derivative is, first we write the same, this is the rule of differentiation, that first exponential function will be same and then the power derivative, that is 1 by x, and the derivative is minus 1 by x square. Minus 1 derivative is 0, I am not writing that, and limit x tending to infinity. 1 by x derivative is minus 1 by x square. You can see this whole term is getting cancelled, and now when I am applying this, now substitute the limit infinity e to the power 0 is, so finally e to the power 1 by infinity, that is 0. So this limit is coming out to be 1. Now changing or taking another problem, and the problem is limit x tending to 0 plus. I hope you understand the meaning of 0 plus. It means you are moving towards the positive or positive side of 0, that is origin. And in this question, why particularly 0 plus? There is a reason. And the reason is because the function is x log x. If you know the function concept very well, you should be knowing that log is defined for positive values of x. That is why I am taking the limit x tending to 0 plus. If I am asking, or if I am taking 0 minus, it means if the function is not defined, how can you talk about the limit? For limit concept, the function should be well defined, then only we can talk about limit of a function. So this is x log x, and x tending to 0 plus, I will not talk about 0 minus because the function log x is defined only for positive values of x. So what exactly this form is? This is basically 0. I hope, and if you don't know, you can note down, log 0 is minus infinity and log infinity is infinity, and log 1 you know it, that log 1 is 0. Rest of the values we have a table and we can use calculator, but these are the standard values you should memorize. So 0 into log 0 is minus infinity. So this is 0 and minus infinity. This is again indeterminate form. And how to solve such a problem? Whenever you have 0 into infinity or infinity minus infinity, the rest of the forms always you convert to 0 by 0 form. So how you can do it? Let's see. So this is x log x. I'll write it in a way that it becomes 0 by 0 form. So, or I can write it like this. There are two ways anyhow. I can keep x here and I can take log x in the denominator, but that derivative, when you will take the derivative, when you will apply the L'Hopital, it will be difficult. So, better you keep log x in the numerator and take x in the denominator. When you are taking x in the denominator, obviously it will be 1 by x, because when you will reverse it, it should be exactly the same function. So now log 0 in minus infinity, so and 1 by 0 again. So this is kind of infinity by infinity form. Whether it's 0 by 0, infinity by infinity, or the rest of the forms, you always convert to only two forms, 0 by 0 or infinity by infinity, and obviously there will be a possibility to convert in such a form. Again you apply using L'Hopital. Rule will be same, that you will differentiate numerator and denominator. So according to the rule, I will differentiate this log x separately. Log x derivative is 1 by x. 1 by x derivative is minus 1 by x square, and limit is extending to 0 plus. So just sort it out. It means just take it to reverse it, and finally the final expression is minus x, and minus x and limit tending to x tending to 0 plus, it is finally 0, because don't write minus 0, because 0 has only one sign. It is not plus 0 or minus 0, 0 is only 0. So finally we are getting the limit as 0. So now take up a different problem, and the problem is, anyhow it's a star problem, and it is limit extending to infinity 1 plus 1 by x to the power x. Exactly what form it is, you can see when you are substituting infinity. This is 1 plus 1 by infinity, that is 0, it is 1 in the bracket, and 1 to the power infinity. This time it is 1 to the power infinity form. How to solve it? How to solve this? First thing is, whenever you have your variable like limit variable, that is x, in the power, you will apply log, that is one thing, and it is 1 to the power infinity. So this is indeterminate form. So this is indeterminate form. Again using the same way we will use L'Hopital, but how come like we will make it to infinity by infinity or 0 by 0? That is anyhow every form, the different form you have to convert it to 0 by 0 or infinity by infinity. So first I am doing, I am letting it as single variable, or you can say function in a single variable by. Whenever you have this, I am telling you to use log. So log x log 1 plus 1 by x. How come? Because log of m to the power n is n log m. This is property of log function. So this is log 1 plus x whole power m. X is in the beginning. So x log 1 plus 1 by x. Apply limit. This side, anyhow limit has no meaning, because it's just y and there is no x, but as I am taking limit, I have to take it both sides, and then I will remove it from this side. Now see what type of expression it is finally. This is infinity, the limit is infinity. This is infinity, and when you are substituting infinity here, 1 by infinity is 0, log 1 is 0. It means this is now infinity into 0 form, and what to do? Either you take this expression in the denominator or you take this expression in the denominator. If you are taking this in the denominator, it will become 0 by 0. or if you are taking this 0 in the denominator, this will become infinity, because 0 if you are taking in the denominator, 1 by 0 is infinity. I am keeping log in the numerator because otherwise the derivative will be difficult, as log function derivative is anyhow becomes complicated. I am taking this x in the denominator. Now see which form it is. Infinity, when you are substituting, 1 by infinity 0, so log 1 0, and now it is 0 by 0 form. So finally we converted the form, and obviously we have to convert, otherwise we cannot solve it. The same question I can do by infinity, and but I am doing it by 0 by 0. Why? To make the calculation difficult. Using L'Hospital or L'Hopital rule, apply. So it is denominator derivative is minus 1 by x square, and numerator derivative is 1 plus 1 by x, and 1 derivative is 0, 1 by x derivative is minus 1 by x square. So limit x tending to infinity. So this gets cancelled. We are left with limit x tending to infinity 1 upon 1 plus 1 by x. Apply the limit. When you are applying the limit infinity, this is 1 by 0. So 1 by infinity, it is 0. So you can just, this is 1 by x, and 1 by infinity is 0. It means finally you are getting it as 1. So my LHS expression was, it is log y, and now I am not writing the limit because limit extending to 0 has no meaning. And now this side there is no log, so it is log e, log y, take it in the power, so log e to the power 1 is 1. So y value, remove log e, what exactly y was? Y was 1 plus 1 by x whole power x, limit x tending to infinity both sides. So you should, I have showed you how this limit is e, this limit finally is e. There is another way or another formula also for this. So this is very important, you can say example, or from a competitive point of view, or from your normal exam point of view also. Another limit the same way, just what you do, x tending to 0, but replace here 1 plus x 1 by x, the same, this also comes out to be e. So these are very, like you can say good problems or good formulas you should memorize, you should learn, and very useful also. So this is end of part 2, and in both the parts, part 1 and part 2, we have taken different problems on indeterminate forms, and the forms are 0 by 0, infinity minus infinity, infinity by infinity, 0 to the power infinity, 1 to the power infinity, infinity to the power 0. Different problems, very important problems we have taken. If you want to know the concept in detail, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. Please like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.